So this video is about exercise 1.10 from the complex numbers chapter, and it's just going through the solutions for question 4 and question 5. So question 4, first of all, asks us to use de Moivre to solve z to the power of 3 equals 8. So what I'm really looking for here is what is z. So if I think about how I'd work this out, well, if I know what the cube of something is, then to get the answer I should cube root the right hand side. But if I was just to use this method, I'd only get one answer. I'd just get the number 2. Whereas I know when I'm dealing with complex numbers that if I am going to cube root, I should be getting 3 different answers. So I need to take a slightly different approach. So the first thing that I need to do if I want to do anything to do with de Moivre and powers is I need to get it in polar form to begin with. So how do I write 8 in polar form? Well, first of all, I'm going to think of 8 as being the complex number 8 plus 0i. Don't forget this form is known as rectangular or Cartesian form. So in order to get it in polar form, I first of all need to draw a diagram. So to do that, I draw a diagram first of all, locating the complex number in Cartesian form. So it's just out at 8 on the real axis in this case. And then to get polar form, I have to decide on 2 things, and they are the modulus and the argument of that complex number. And actually, because this complex number is located on an axis, it makes it really easy to get both of those things. So the modulus is simply the distance from the origin. And of course, you could work it out using the formula, the square root of 8 squared plus 0 squared, but that's just going to give you 8 as well. And you can really see it very clearly as a distance here on the axis. So we don't need to go and actually use the formula unless we really want to. And then we want to get the argument. Well, the angle that I'm creating with the the positive sense of the real axis here is actually 0. So the argument of 8 or 8 plus 0i is just 0. So when I go to write this complex number then in polar form, I'm going to write it as z cubed equals 8 times cos 0 plus I sine 0. Now, so we said earlier that like if you're dealing with it in regular algebra, you'd probably just cube root. But because we're dealing with complex numbers, we need to take a slightly different approach. We'd never really cube root as such for a polar form. Instead, what we do is we use a fractional exponent. So that means I'm going to use a power of 1/3 on this complex number. But just before I do that, because I'm going to want to use a fractional power, I also have to introduce my general form for the angle. So I'm not going to just say 0 here, I'm going to say 0 plus n360. Okay, so now I'm going to use de Moivre. That was my instruction in the question. And de Moivre's theorem just states that if I've got a power here on a complex number in polar form, that I can apply the power to the modulus, and then I can multiply the value of the power by the angle. So I'll do that now. And I could do with a little bit of tidying up here now. So 8 to the power of a third, well, that's just another way of writing the cube root of 8. So that's just going to work out as 2. You can work it out in the calculator if you like. And then when I go to tidy up in here, well, obviously 0 plus, I can effectively leave out those zeros. They're not going to do anything extra. I'm just multiplying the 1/3 by the n360 in both cases. Okay, so I'm getting closer to an answer, but I'm not quite there yet because I've got these n's and I want to have an answer that's just a regular complex number. So now what I need to do is I need to substitute in a number of values for n. And I'm going to need to, in this case, put in 3 values for n. And it's 3 values because originally we had z cubed. And we're going to also, we're always going to start at 0 for n. So n equals 0, n equals 1, n equals 2 will be our values for n in this case. And I'm going to substitute those 3 values for n into this polar form of the complex number, and it'll spit out 3 answers for me, and they will be my 3 solutions then for z. And if the question doesn't specify, I could probably leave them in polar form like this. But generally what you'll find is that they'll either ask you to write it back in a plus bi, or you'll feel an obligation to present the answer in the same format that they asked the question in. So it's just like a little bit of etiquette, if you like. And of course, it's really easy to evaluate this just using your calculator. So all you have to do is just type in cos 0 and sine 0 and see what you get for those. And the same for cos 120 and sine 120, etc. So using your calculator, when you convert these complex numbers back into Cartesian form again, you should be getting your 3 solutions: z equals 2 plus 0i, z equals minus 1 plus root 3i, and z equals minus 1 minus root 3i. So don't forget again, you can kind of tell in advance how many solutions you're going to have depending on what the original power is. Question 5 says find z if z cubed equals minus 8 and give your answer as a plus bi. Because that question is actually so like the question 4 that I just did, I'm actually not going to make out the solution for it just yet. Give it a bash yourself and see if you can figure out what the 3 solutions should be. And again, you're going to expect 3 solutions because you're trying to find z knowing z cubed.